Hi. So in this video, we're going to look at improper integrals. And an improper integral is an integral in which either at least one of the limits is infinity, or the function to be integrated approaches infinity at some point in the interval of integration. So in example 1, we've been given 4 integrals, and we're going to look at which of them are improper and why. So if we look at the first one, well, we can see that the limits between -2 and 2, neither of them are infinity. So for that reason, it may not be improper. But if we look at 1 over x squared, we need to see what's going on here. So if we look at this as a graph, so if we start at -2 and head towards 0, you can see that the curve is increasing exponentially until x equals 0. And at this point, there is no solution, because when you divide by 0, this is undefined. And then as you go past 0, we shoot down from infinity. So because this function is broken, this is an improper integral, because we cannot divide by 0. Okay? Okay, so for our second integral, well, again, neither of these limits are infinity. But if we look at x over 1 minus x squared as a function, well, you can see when x is 0, and this is defined, but then the function becomes undefined when x approaches 1. You see we've got a broken scale as it shoots off to positive infinity here, and then negative infinity just after 1. So again, for this reason, because 1 is inside of our limits, this becomes an improper integral. We can say it is an improper integral because x over 1 minus x squared is undefined when x equals 1. For our third integral, well, you can see this is an improper integral because we have infinity in our limits. So we'll say this is an improper integral because the upper limit equals infinity. And our final integral, well, within the range of -2 to 1, this is proper. But if we look at this function, we can see within the integral range of -2 to 1, every point is defined. The function is not broken. So for this reason, this is a proper integral. Okay, so in example 2, we're going to look at improper integrals which diverge and converge. So let's try question 2. So an integral is said to be convergent if it converges to a value, and divergent if there is no numerical answer when evaluated. So we'll look at each of these in turn. In example 2, we're going to look at a convergent integral. So we've been asked to find the integral between 0 to infinity of e to the negative x with respect to x. But the problem is, we cannot calculate with the infinity because it is undefined. So what we do instead is we have another variable which we can call t, and we say that t approaches infinity. And then we have the integral between 0 to t instead of infinity of e to the negative x with respect to x. So we can't calculate with infinity, but we can let a variable tend to infinity. So we can evaluate this integral. We'll have the limit as t tends to infinity, and then the integral becomes -e to the negative x between 0 to t. And we can substitute in our limits, and this becomes -1 over e to the t minus the -e to the negative 0. And we can simplify this as the limit as t tends to infinity of -1 over e to the t, and then e to the 0 becomes 1, so this becomes -1, and subtracting a -1 becomes a +1. So now we need to say what happens when t approaches infinity. Well, as it does, the 1 is divided by a very, very big number. So this term becomes 0. So we say as t approaches infinity, -1 over e to the t approaches 0. So therefore, the integral has a value of 1. but it never actually reaches 1 because t never actually reaches infinity. So what we say is, this converges on 1. It is a convergent integral. Okay, let's try example 3. Okay, so for example 3, we're asked to show the integral between 0 and pi over 2 of tan x dx. But to begin with, I'm going to show why this is an improper integral. Okay, so here we have the graph of tan x. And you can see that as we start at 0, the lower limit of our integral, the function is defined. But as we approach the upper limit, pi over 2, tan x becomes undefined. So for this reason, within our limits, tan x is an improper integral. So we'll evaluate the integral as the limit of t approaches pi over 2. And we'll have the integral of 0 to t of tan x with respect to x. And this is a standard integral provided in the Edexcel formula booklet. So we'll have the limit of, as t approaches pi over 2, of the natural log of sec x between the range of 0 to t. So now we can substitute in our limits. So we've got the natural log, and the sec x I'm going to write as 1 over cos x, so 1 over cos t, minus the natural log of 1 over cos of 0. Well, we know that the cos of 0 is equal to 1, so this becomes 1 over 1. And the natural log of 1 is 0, so this becomes 0. And then we have a natural log of cos t. But as t approaches pi over 2, cos of t approaches 0, which means 1 over 0 becomes undefined or approaches infinity. Okay? Because it's undefined at this point, we say this is a divergent integral because it cannot be calculated. There is no numerical solution to 1 over 0. Okay? Well, thank you very much for watching. I hope you found that useful. You can download the full lesson and worksheet from my website, mrmathematics.com. Another link in the description below. Thanks again, and take care.